Okay, so good morning all. We are meeting today under the aegis of Azadi ka Amrit Mahotsav and also Golden Jubilee of IIG. Today we have a very distinguished guest to interact with us, Professor Arnab Bhattacharya. Professor Arnab Bhattacharya is a scientist, tinkerer, and a science communicator at the Tata Institute of Fundamental Research in Mumbai, where he leads a research group in semiconductor optoelectronics and is also the center director of TIFR's Homi Bhabha Center for Science Education, Mumbai. Arnab has a BTech degree from IIT Bombay, MS and PhD degrees from the University of Wisconsin-Madison, and he's done a postdoc at the Ferdinand Braun Institute in Berlin before coming back to TIFR. Beyond the research lab, Arnab is passionate about science outreach and enjoys talking about science and demonstrating science experiments to all audiences, particularly school, college students, and he also is interested in developing low-cost science experiments. Arnav has pioneered Chai and Wai, Mumbai's popular science cafe, and is presently the chair of science popularization and public outreach at TIFR. Arnav has received many accolades and honors, the first of being the 2010 Homi Bhabha Award in Science Education. In 2012, he received the Chevening Rolls-Royce Fellowship for Science and Innovation Leadership. And in 2017, the INSA Indira Gandhi Prize for the popularization of science. He also has a whole bunch of crazy interests, including music, cooking, hiking, photography, marathon running, etc. So before I hand over the floor to our guest, I would I'd like to make an announcement regarding keeping your mics mute during the session. And if you have any questions while the speaker is talking, you can type into the chat box. So that those queries will be taken after the talk. And after the end of the talk, you can anyway interact directly with the speaker. So I'll request Professor Arnab to start his lecture, please.
Thank you so much, Praveen ji. Thank you. It's a pleasure to be speaking to you, unfortunately, virtually. So Praveen and I have been, we meet for every outreach excuse there is, whether it is National Science Day or the Founders Day at TIFR. And, especially because IIGM is very close to us in Kolaba, the old campus. And unfortunately, I have not been able to come to the Panvel campus as yet, but I'm slowly getting near there. I'm halfway there now. So maybe one of these days when the restrictions are lifted, I would have loved to come and give this talk in person, but the times are such that it's online. So when I was asked, what do I speak about? I said, I have nothing to do with geomagnetism. I am a semiconductor scientist and I work with now science education. So I thought, okay, the one thing that I can talk about is something which everybody knows now, everybody uses, which is this, the mask. So we are all wearing these masks. They come in different, shapes, sizes, whatever, different types. We'll go through this. So I thought, let me talk about masks, because for many people, I think how this mask works and what is its role in, especially in a time like the COVID crisis, is something which the science is actually very poorly understood. So by most people. So let me see if I can share my presentation. Okay. Okay, now I have to make sure that I minimize all these things so that you don't see me. Pravinji, is this good? Can you see my screen?
It's okay, yeah.
Yeah. So, okay, the only thing is I can't see anybody, but that's all right. So please put your questions in the chat. We'll take them at the end, certainly. So I'm going to tell you some stories. I'm going to tell you some stories of different types of masks, how they filter, whether we can reuse them. That's, I think, a very, very critical issue. and we'll look at some of the work we've been doing in this. Okay, so the different stories I have is, first we will start with exactly what is a mask, how does it filter, and then I'll tell you about the story which happened during the COVID lockdown. In the last 1.5 years, my lab has been closed, but I have been working full time on masks. And in collaboration with Tata Memorial Hospital, we actually came up with a procedure to reuse these masks, and I'll talk a bit about that. And then once you have the ability to measure the filtration efficiency, you can do lots of fun stuff with it. So we'll tell you all that you can do in your kitchen. And let's see. So the common thing is, and this is what I tell people in, especially when I talk to school kids and people, the public, that you will see that there is no division between this is physics, this is chemistry, this is biology, this is engineering. This is something which actually combines everything, everything. So I hope you enjoy the stories. And the other thing is, it also says that in today's world, we have to collaborate. We have to collaborate with lots of people, and collaborations are the way we make progress. So we'll see a little bit about this. So first, I need to thank all the people who helped me at TIFR. There is Shankar Ghosh, another professor there who's been sort of my partner in crime in all of this, and many of our students and staff who've helped. And also all these masks have come from Tata Memorial Hospital. So they are the ones who have given us a lot of masks for testing. And I learned a lot by joining an international group called N95 Decon for decontamination. So there are a lot of people who've contributed to this. Now, masks are nothing new. Every culture, for thousands of years, almost 10,000 years, has used masks. These masks were for various things. They could be for entertainment in a dance. They could be just for disguising yourself. They could be for some kind of protection. And protection is what we are at. So, right from the Inuit, the people who live in the very cold regions in North America or Greenland, etc., they have used masks to protect themselves from the glare of the sun. In the 17th century, when there was the plague, people had these very funny looking masks, which looks like a bird's beak, where they thought if they put some nice smelling stuff, eucalyptus oil or something, it would help. They didn't know what caused the plague, so there was no thing. Today, of course, we have these masks, and whether it is the COVID warriors in the hospitals who are wearing them, or whether simple public is tying a dupatta around their nose, you need to protect yourself from something you don't want. So with all these different masks around, what is the difference in these different masks? What are they good for? What are they not good for? So if you go back to, let's say, a standard source like CDC, the US CDC that controls all this, they tell you that there are basically two kinds of masks. So there is what is called a surgical mask. These are these blue kinds of masks, okay? And there are what are called N95 respirators, which are things which look like this or like this. These are N95 masks, okay? So what is the big difference? The big difference is they say, well, this mask, the surgical mask, it's called surgical because the doctor wears this in the operation theater so that his or her spit, body fluids don't go out to the patient. So it protects somebody else from the wearer. On the other hand, an N95 mask, this is designed to filter very small particles, and it protects you from particles in the environment. Hence, this by design is loose fitting, whereas the N95 is a very tight fitting mask. Okay, so this is of course very qualitative. What is small and large? Okay, but to understand that, we need to go to Act 1 of our story, which is what does a mask do? But by the way, before we get to that, let me also just quickly tell you this. Everybody asks me, why is this an N95 mask? Well, it's a US designation. It just says the N that it is not resistant to oil. Okay, N for non-oil resistant. The 95 tells you that it filters 95% of particles of a particular size, and that size is 300 nanometers or 0.3 microns. Okay, and this is a big source of confusion, especially in India. There are multiple size ranges for which people make measurements, and they said ye 95% hai, so N95. But not every night, you have to be careful what it is. We'll come to this in a bit. So what do you want for a good mask? A good mask should be able to filter. That is, whatever you don't want to breathe in, It should not allow it to go in. On the other hand, it should not make breathing very difficult. So if I take a stainless steel vati and I put the vati on my nose, that is 100% efficient. Nothing goes through a stainless steel vati. Okay, but you can't breathe through it. So it's not useful as a mask. The other thing is, it should fit properly. Now, these masks by design are such that it is loose over here. It's loose at the side. Okay, so the fit is very important, and also how comfortable it is. If the mask is so tight that it's not going to be comfortable, people won't use it if it hurts the ears. If, for example, many people have problems if you wear a mask, if you wear specs like me, the glasses get fogged up, also not very good. So, how do you avoid all this? This is what goes into making a good mask. Now, the first thing is, how do you keep out stuff that you don't want? You can go back to the CBSE 6 standard book. The CBSE 6 standard book tells you that there are various ways of separating things. You can separate tea leaves in the morning when you make chai with a strainer. You can, when you have some grains and you want to pick out the stones, you can do it one by one. Or the most common way is, imagine what happens when you have somebody who's trying to you have sand or reti or something like this at a building construction site. They take it, they throw it on a mesh, the fine particles fall through, the coarser grains fall off. This is basically what filtration is all about. Now you have to wonder, what am I trying to filter? In our case, you have something in the air, you have a mask in the middle, and you have something. This is going to reduce something going through. So what is the size? What am I going to filter? So this is where the first thing to look at is, what is the size of particles around that we need to worry about. So let me see if I can get my pointer. Yeah. So most of the bacteria in the air are actually pretty big. They are between, say, 1 and 10 microns. All the fungi, pollen, all these things. These are the things which will make you sneeze, pollen, dust, etc. These are large. These are microns and tens of microns. Bacteria are somewhere around a micron. Viruses are much smaller. They are typically between 20 nanometers to about 0.3 microns, 300 nanometers. Now, of course, the SARS-CoV-2 virus is about 160 nanometers, but mostly you don't worry about an individual virus, because if somebody is infected and they sneeze, it's going to mostly go with a droplet of water. So you're interested in that size, not necessarily the virus size. But remember, all these bacteria and viruses, etc., they can also break up, and there are fragments which have a wide size distribution. So I need to filter particles of different sizes. Okay. So please let me know if things are going okay or not. There's no feedback I have for the audience. It's very difficult for me. So we will look at a little bit about what is happening when we cough. Okay, how do these droplets come when we cough? Koi cheekta hai, so what is happening? Okay, so generally what happens is, in our throat, right, there is a little mucus lining. This is a very coarse, sketch. Some particle which is going to irritate it comes inside. It gets stuck to the lining, and the body wants to throw it out. So you send a gust of air out, and that gust of air throws out that particle, but it also breaks down this little mucous membrane that is there and generates the droplets. Okay, and this is a case where you see it. This is why you cannot. So it is biology what is happening, you'll say, inside the throat, but it's also physics, because you have this layer of mucus, you have a sudden gust of fast flowing air, and this is going to cause some instabilities in this. Okay, and these instabilities, these are sort of called Kelvin-Helmholtz instabilities. These are what break up this layer and give you these droplets that are finally going to be ejected by somebody who is coughing. Okay, and this thing, the other beautiful thing about physics is its length, operates at various length scales. So when I give this talk in schools, I show this picture that you get these same patterns due to Kelvin-Helmholtz instabilities in nature and cloud patterns. And at IIGM, I thought the correct picture to show is this, that you see the same patterns when the solar wind interacts with the Earth's magnetosphere. I'm sure you've seen these patterns, but this is the same pattern that you also see when somebody is coughing. This is the way the cough droplets are generated. Okay, so now you have a size distribution of cough droplet. It also depends on how it is produced. So coughing, of course, generates a lot of these small droplets. So this is, talking, breathing, breathing through your mouth, coughing, etc. And the number of droplets of different sizes. So this side is large particles, small particles. So coughing generates a lot of these, particles which are about a micron or slightly below of a micron. Now, when you have a sieve, when you have something like this, a gardener or a sieve, at first thing you will say that, okay, if I have an opening, if I have something which is a size larger than that, it will not go through. If it has something smaller than it, that it will go through. This is because, physicists, we always like to think of, like, the simplest thing we think of is a sphere. But in the practical world, remember that not all the particles are spheres. If you have a particle which is like this, which is elongated, one side much bigger, other side much thinner, a needle-like particle, depending on the orientation, you can actually go through a sieve like this, even though this is bigger. So if the particle was this way, it would not go through, but this way it will go through. So orientation, there are multiple length scales that are coming into this problem. Also, in a mask, you have some place where these particles are going to come and get stuck. But you're also breathing through the mask. There is some airflow. There is also probability. There is a rate at which particles are getting stuck and particles are getting unstuck. And you want, hopefully, that the rate of getting unstuck is not large. Okay. So there are various mechanisms by which you can filter. The simplest thing is, this mask has fibers. A particle comes, dhram karke hits the fiber, gets stuck. So this is like exactly like a football. The goalkeeper stops the kick, stops the ball. So this is interception. Okay. And remember, these particles are flowing along the streamlines of air, but if they are going close to the particle, they can get stuck. There is also other effects that help you. So just like on a car, if you go too fast on a bend, you will skid outwards. Similarly, there is inertia. The particles can't always follow the particles have some mass. They cannot follow the streamlines of the air. So they just go in their original path and they hit the fiber. So you can also have inertial impact. Okay. The other thing is there is diffusion. So just like some drunkard who is walking and bangs into a pole, particles are going to have some diffusive movement, and even if they are not exactly hitting the line of on the line of thing, because they are moving around, they could go and hit the fiber. So there is actually some gain that you get. So because of this, a particle which is actually this small, and if it was going in a straight line, could go in real life, because of the particle moving around, the particle being has to follow the streamline. Effectively, the particle diameter is slightly bigger. Okay, the effective size. So this actually helps you filter. You don't need to make these things very small. But that is only one part of the story. The way all of these masks work is actually using electrostatics. So if you charge up something, you can attract things. And that is what is used. Just like a comb attracts these pieces of paper, you charge the fibers of the mask and they attract particles. So even if the cough droplet is uncharged initially, as long as there's a field, there will be a gradient and you can attract these particles. So a lot of these small particles are actually attracted electrostatically. So to be in effective filtration, you cannot really reduce the size of your mesh. If you reduce it very small, it will not be breathable. So for the large particles, it's almost like the way we filtered sand. It is mechanical. For the small particles, 300 nanometers and below, it is mostly electrostatic filtration that is used. And if you look at an N95 mask, this mask has various layers. The layer that does the filtration in the middle actually has gaps which are much larger. Is there a question? Okay. There are gaps that are much larger, but because of electrostatics, they can attract the fine particles. So because of the larger gaps, it's breathable, but because of electrostatics, it works. Okay. So if you have a cloth mask, whether it's a dupatta or whatever you put, that is basically trapping mechanically, where the filtration is determined by what is the separation of your pores. But if you make that separation very, very small, if you made it 300 nanometers or 0.3 microns, it would be almost impossible to breathe through it. So the solution in N95s is to have layers which have large spacing but are charged, and hence they attract particles. This is why reusing an N95 mask is very difficult. You can wash your hands in water, With soap and water, it'll go away. You sanitize your hands with alcohol, 20 seconds, you're done. But once you put this mask in alcohol or in water, you remove the charge. And if you remove the charge, you kill the filtration efficiency. That is the problem. Okay. And this is just some electron microscopy studies. Just remember the yellow bar is 200 microns. Okay, not nanometers, microns, 0.2 millimeters. So the outer layer is just called large size fibers. Inner layer is very similar. In the middle, there is this layer of very fine fibers which are electrostatically charged. Okay, and again, this is not the gaps are not 0.3 micron. This is a 200 micron bar. Okay. Also remember that while a mesh, the way we showed the teacup, the tea strainer, it's a single sheet. This is not a two-dimensional problem. This is three-dimensional. There's a width to that. The mesh that I showed you here. There's a width to it. So it's like, you know, the particle has to go through this, and the chance that it will hit or interact with it somehow electrostatically or mechanically is very high. Okay, so this is how you filter. Now, the problem is surgical masks, at least in India and even outside, they are sold, or the specifications that they have to meet for the Indian standards or whatever is that their bacterial filtration efficiency must be larger than 95% at 3 micron size. The N95 has to have a filtration efficiency of 95% at 0.3 micron size. So there's a factor of 10 difference between this and this. And be very careful what is written. Many of the cheap vendors will measure bacterial filtration efficiency and say, "Ha, 95 mil gaya, to N95." Okay, so this is the main problem. Okay, so this is the sort of background on how masks filter. Praveen ji, I hope you are doing okay on time and all that so far. I hope people are.
Yeah, no problem, sir.
I can't see any questions, so I don't know how things are going.
They will type in later, or they will ask you after the end of the.
Okay, no problem. So let's rewind more than a year back. End of March, the lockdown starts. 3rd April, lockdown. You know, this is a typical picture of Mumbai. I get a phone call from Tata Memorial Hospital saying that the hospital is running out of N95 masks. Somehow, kuch to karo. We need to reuse these masks. We need to decontaminate and reuse the masks. Figure out how to do it, please. I don't know how they got my number, why they called me. I like to tinker with stuff. Maybe somehow somebody told them. And I said, okay, try karenge, we'll do it. And little did I know that this was going to be a year's journey. And, you know, what do we do? So now the people who work on viruses, virologists, bacteriologists, whatever, the biologists, basically, they know how to kill the virus or zap the virus or inactivate the virus, whatever it is. Okay, that is not my job. I'm a physicist. But whatever you do, whether you use radiation, UV light, heat, sterilization, you know, whatever, autoclave, you have to make sure that the mask material is not damaged, that it still filters, right? And to measure the filtration efficiency is a physics problem. And of course, there are instruments that do it. You can buy a mask tester. It costs 20 to 50 lakhs. This is the lockdown period, not available anywhere. Even if you had 20 lakhs, you cannot get it because the US has said, you know, we are not selling. Apne ko bhi chahiye, hum log nahi de rahe hain. No export permission. So there is no mask tester available. So how do you measure the filtration efficiency of a mask in a cheap manner? Now the idea is this. What we used is, currently everybody is interested in air pollution. And you must have heard these numbers like AQI. Aaj AQI itna hai, 200 hai. Delhi mein AQI is going above 500. Diwali time it's gone up, shot up something because of crop burning. This is happening. AQI is going up. Air quality index, what is that number? When they say AQI 10, it is a number of 10 micron size particles in some volume of air, or AQI 2.5. Given that pollution sensors are available in many places, those things have an optical sensor in them which measures the number of particles. So suppose I have some air, ambient, which has some particles. I pass it through the filter, the mask in this case, and I measure how many particles are there per unit volume. So if I have the particles going through the mask and the particles in the ambient, from that ratio, I can figure out what is the efficiency of the mask. So we started working on this principle, looking at how do we measure it using light scattering first. We figured out that it's much easier to use one of these standard pollution monitors. We first had it in a little plastic dabba. Everything, this is in the hard lockdown case. This is built at home with whatever we could get home and lab. But these are toys stolen from my daughter's, and balls stolen from my daughter's toys. This is all wooden planks, whatever we could get in the lab, ghar se dabba. We just use this to measure the mask efficiency, and we had something. But this is the beginning, as they say, picture baki hai. Now, what we made is this, and remember, you always have to give nice names. So we didn't make a mask tester, we made a mask integrity test resource, because we could call it Mitra, my friend. So the idea is this: we didn't have a, most of the commercial testers have a model of a face, a mannequin on which you can put the mask. We didn't have that. We just used a ball. We just used tape to tape the mask on the ball so it doesn't leak from the sides. We have a little pump, and we suck the air through the mask. One of the issues is these particle counters. They have very small fans inside them, because they're just sampling the air in the environment. For a mask, you want to make these measurements at least the rate at which you are breathing, and human breathing is like 12 liters a minute or something. So you have to measure at least that much flow. So we have basically some way of having a pump, pulls air through this, through a flow meter, through this sensor, and then out we measure the number of counts. And we decided we would make this. This was a pandemic period. We put up everything online on GitHub. We were, people were asking us, why don't you commercialize it, sell it? We said, this is a pandemic, let everybody access this. So we put up all the designs in public domain on GitHub. Okay. And this cost us only 20,000, not 20 lakhs, because it was just a homemade thing. But once you have a mask tester, that's when the fun begins. Of course, this is the first step to figure out how to do decontamination. But we could do many things. We could give feedback. Lot of people were donating masks to the hospital, and they were giving us the mask to test acha hai ki nahi hai. And we found there were a lot of fake masks, lot of fake masks, huge problem in India. So we used to test every mask. Every time a different sample of masks came to Tata Memorial Hospital, they would send it to us. We would test it and tell them ki ye theek hai, nahi hai. We also did some cool experiments. I will come to it later on some real science with the masks. We helped different groups. We helped groups in Pune and Ahmedabad and a lot of Baroda and other places design these masks. We helped a startup company. We started to see if we could actually make mask testing machines. And we did some other cool experiments on washing masks and sterilizing masks. But of course, I said, remember, the aim that Tata Memorial Hospital wanted was to reuse the mask. Okay, making a filtration thing is one step. So how do you decontaminate and reuse? The main thing, you want to inactivate the virus, but you don't want to change the filtration efficiency. And these masks have traditionally, nobody's had worked on it, because these masks were designed to be used and thrown. Nobody thought that everybody in the world will use it. Itna sara kachra banega, there will be no amount, this is not biodegradable, but people have worked on it now. Now, just remember that people use the word sterilization and decontamination. Now, as a scientist, we were doing decontamination. Decontamination is where if I had some amount of bacteria, virus, whatever it is, after the treatment, 99.9% reduction, which is what is the community calls 3-log reduction. If you're doing sterilization, that is 99.999% reduction, 5-log reduction. Okay, we are happy with decontamination for a mask. The main thing is this viral inactivation should not impact both filtration efficiency and fit. And often it is not the filtration. Either your straps will break, or there is a nose clip here that can break and come out. So all of these are things. Thankfully, there are groups which had studied this, and there was a consortium called the N95decon.org. I joined them, and people knew that, for example, alcohol-based sanitization or just soap water and detergent, they will reduce the efficiency because they remove that charge. I spoke to you, it's all about charge. Bleach solutions also, same problem. Also, you don't want anything with chlorine left on the mask when you're breathing it next time. Similarly, ethylene oxide. In hospitals, they use ethylene oxide for sterilization, but that's okay for surgical tools and all. Any ethylene oxide is very poisonous thing, so you don't want to have any residue on the mask. Gamma ray works. You can use it for irradiation, which is what DAE was also trying. But the problem with the gamma rays is they also damage the polymer. So they also remove the charge, so it doesn't work very well. Sunlight, it does not have the UV necessary to kill the virus. So that doesn't work. What works? Well, there are some chemical processes that work. One of them is hydrogen peroxide vapor. There were some companies in the world that have these. This is a huge scale. You can do 10,000 masks at a time, but it requires very sophisticated facilities. The simplest thing is time. You have a mask, you've used it, there is some viral load on it. Just keep the mask, keep it outside in the air, just keep it for more than 5 days. In 5 days, the number of the viral activity goes down to more than 99.9, by more than 99.9%. So if you use it on day 6, that's fine. This is the simplest way to do it. If you have 5 masks, use a mask on Monday, Tuesday, use a new mask on Monday, Tuesday, Wednesday, Thursday, Friday, use the Monday mask again on Saturday. That's also possible. That's the easiest way to do it. The other thing is use heat. Heat, we know, that's how most sterilizing and autoclaving works. It's heat. Or you can use ultraviolet light, UVC, but with care. So there are something. So we thought, in the Indian context, time is the easiest, but then you need 5 times, and one person needs 5 masks, so 6 masks at a time. Heat was probably the easiest one to implement, and we started working with heat. So I am a scientist. So in the lab, what I did is I tried to make sure that the filtration efficiency won't change. I wanted to make sure that the mask reaches the temperature. So I was sticking temperature probes on the mask, making sure the temperature, how long does the mask take to come to thermalize and get to the temperature. I used a very small oven in TIFR to do these measurements, measuring humidity and the temperature, etc. Lots of fun things happened. We tried to use the water boiler for making chai, coffee. We put it in that, ruined some masks. We once put a temperature, the room temperature monitors. These are the cheap ones you get. You put it inside the oven, and it says it's okay till 100 degrees, but what you get out is a nice modern art piece of plastic at the end. We tried lots of fun things, but 70 degrees, 70 minutes or 75 minutes. Now we're at 75 degrees, 75 minutes. It works. We tried different models of masks. Nothing happens to the efficiency. It's still at 95%. Surgical masks, they come in different types, but even those, you can heat treat them absolutely fine, not a problem. Okay, it works. It works is great. In the lab, tests on one mask. Now you have to scale it up. And this was a challenge. We took it up to the hospital. They wanted to have at least 200 masks a day. So we had a large cupboard. This is like a Godrej side cupboard thing. You'll see them in the malls where they keep fridges. They have large fridges where they keep stuff. It's a very similar thing. It's a hot box. It's a hot box at 70 degrees. Now you have to keep the mask inside. And a very important thing is, people had done this. It's not that we were the first person using heat. People had done this. There was a preprint on medRxiv. These guys are using what they call Rubbermaid boxes, plastic dabbas basically. But to put the mask in the plastic dabba, somebody has to take it out, put it in a plastic dabba, seal it, and then put it in there. That involves touching the mask. Remember, out here in the hospital, the decontamination will be done by the sterilization department, where they just have some technicians doing it. It should be something that an untrained person can do. Tata Memorial, thankfully, is a cancer hospital. In their chemotherapy department, they had lots of vomit bags. So we just use these paper bags, vomit bags, and the doctors were told, you just put your mask inside the bag, write your name and thing outside the bag. So when it comes, it used to come in cardboard containers like this. The person does not have to touch the mask. They just pick up the paper bag, put it in the oven, take the paper bag out. It's got a name and a number. It goes back to the same department. To work all this out, which department sends on which day, what is the process? This thing was quite a challenge. We started at the end of May. This was at the peak period in the first wave, was being used 2 to 3 shifts a day. And more than 10,000 masks were decontaminated. More than 1,500 doctors, nurses, healthcare workers used it. It's probably the first heat-based decontamination system, not writing a paper, but it was actually used in a hospital. And this was very, very satisfying to see that something in the lab was actually being used. So, Tata Memorial Hospital is a very good hospital. What do you do in places which don't have these resources? And this is something which I was discussing with some colleagues and collaborators at Stanford. Manu Prakash's group. Manu Prakash is the person who came up with the fold scope. Can you do this without all this fancy temperature control? no electricity available. What do? Well, I can always heat hot water. I can heat hot water. चूल्हे पे कर सकता हूँ, गैस पे गर्म कर सकता हूँ. I can burn wood and heat hot water. As long as you can heat hot water, we will take two steel or aluminum or whatever. We will take two vatis. You don't put the mask in the water. You put hot water inside a vati. You put another one inside, and you put the mask inside the. You create a hot zone and keep the mask inside it. So this was being done. We did the similar experiments in one of my colleagues' kitchen in TIFR. We were putting this thing. We put again temperature sensors, etc. Then I thought, okay, why not? Why stop at one mask? Why can't we do multiple masks? So in India, many of us have this in our kitchen. This is the idli cooker के अंदर जो idli बनाने का plate जाता है. So we use this, and in every layer of the idli rack, we used to put masks, and we could do 4 masks at a time. Again, this is one vessel inside another vessel. Very easy way to do it at home if you want to do it. So again, of course, I am a scientist. I did the proper experiments. I took data, connecting sensors, measuring temperature, humidity, etc. Make sure that the efficiency is not changed. So this is actually now published. Then I met lots of fun people in this entire journey in the last year and a half. I met Amog. Amog is he mechanical engineer from ISC who now works with the tribal community in Nandurbar, trying to make solar mirror furnaces and cookers. And we thought, can we use solar energy? Of course you can. You can put your masks inside a typical solar cooker. The problem with the solar thing is you have to take care that you reduce the intensity, because you don't want the mask to go above 90 degrees. If you go above 90 degrees, the polymers will get damaged. So we just try to do this by putting it early morning or something when it won't get too hot. Using only a 10x concentrator. A 100x concentrator is very good if you want to incinerate things. We don't want to do that. So we did some experiments with this. Again, taking data very carefully. Typically in the day, the sun, if you measure the temperature, the red line is the temperature goes up like this and comes down. These are experiments. We had moved to Ahmedabad because at that time the monsoon had already come to Maharashtra. Some days were very cool. You get data like this where in the morning it goes up and then suddenly goes down and comes up again. Of course, this is a cloud in the afternoon, so this is slightly different. But this morning dip that day, what was happening was very cool. This was a solar eclipse that day. So we actually saw that the temperature of the solar cooker went down. Anyway, then after this, I worked on a project with doctors in Bangladesh. And the idea was these masks, can you wash them? And what's the difference between, you can get them for 3 rupees, you can get them for 10 rupees, 11 rupees, whatever. What is the difference, right? And the difference is, what is the layer in the middle? This is melt-blown polypropylene. Is it charged? Is it not charged? And again, some of these expensive masks, they actually use the same material that goes into the N95, it's just the shape is different. So some of these masks actually have 95% plus filtration efficiency. Some of them, not all of them. Okay, so it depends on what you have. So we did some experiments. I won't take you to the details, but we wanted to do this was for a clinical randomized control trial that was going to happen in Bangladesh with 350,000 people trying to use masks and washing masks. So the washing protocols were designed by us in TIFR. So we were using standard, detergent tikya to wash your mask. Initially, the mask is hydrophobic. It has these drops that come on it, but then eventually it'll let water soak through. Then we dry the masks, we measure them, and we saw that how the filtration efficiency actually stays around 80% for some of these good masks, which is not bad. It's better than a cloth mask. So we also did a lot of comparison tests on looking at microscopy, etc. And at the end, we did some cool science. Now remember that if your problem, as I've said, is that you're losing charge, okay? If you're losing charge, can you somehow restore the charge on the mask? Can you get the charge back? Okay, why don't I charge it? How do you charge it? Well, I can take the mask, put it between two plates of a capacitor and charge it using a DC power supply. So that's what we did. It's 95% initially. You wash the mask, it goes down to 75% because you've removed the charge. You put it back, charge it, you can get back to 95%. Then we thought, okay, by the way, how did we get this high voltage power supply? We're putting a 2000 volt power supply. So of course, initially in the lab, we had a TIFR, there's no problem. We could find a high voltage power supply. Then we thought we will make what we call a smart mask. We will make a mask where we keep the filtration material sandwiched between two layers of metal mesh, and we'll apply a voltage to it. So we want a very compact voltage source, high voltage source, which will fit within the mask itself and should be running off a pencil cell. That's the mask. And what did we use for the DC power supply? Well, if you've gone to any railway station, BT subway, etc., they sell these mosquito rackets. They call it kosu bat in Tamil. So these things to kill mosquitoes, those actually have a very small voltage converter in them. We were using that to generate the voltage here, and we could try to make a smart mask. Of course, this was more like a prototype. Then we did something more. But right now, I think I want a lot of time for discussions. I can talk about how we figured out what masks are fake, what is the what mask should you use or not use, and things like this. But let me first say that the take-home message at this point is that we designed a compact, low-cost mask testing setup where we could test the filtration efficiency of masks, and there is a huge variety in N95 masks. Okay. Also, there's a huge problem. There are lots and lots of fake masks in the market, and it's impossible, since with your eye you can't see charge, it's impossible to say whether a mask is good or bad. But N95 masks, they can be decontaminated and reused. Heat is a very simple way to do it. We did this and deployed it at Tata Memorial Hospital, but you can also use this hot water, solar energy, etc., etc. And even these surgical masks, you can wash them and reuse them at least a few times. And just remember the amount of medical waste we are generating if everybody's going to use this and throw it. So even if we recycle it a few times, I think it's a huge saving. We've learned a lot of things. So we also petitioned the government to ban masks with these things. So many masks have exhaust valves. These masks were not meant for COVID. They are meant for people who are scraping walls, working in dusty environments, etc. And people will wear them for 8 hours a day. So you provide a valve. A valve has a rubber gasket. The gasket opens when you breathe out. So when you breathe out, the gasket will open. So you have a zero resistance path for the air to go out. So it's easy. It's much easier to breathe out. At least breathing in, there's some extra effort, but breathing out is easy. And this valve, because it seals, it will not allow anything in. Now, this is a very bad idea, because in COVID or for medical applications, you want the mask to protect people around from whatever the patient has. You don't want a zero resistance path on the way out. Also, if you are in Mumbai, in a humid environment, you're wearing this mask. There is basically a hole in which this thing fits, right? This rubber gasket is going to collect some dust. It's going to get moist. It will trap some dust. Once it collects any dust on it, it doesn't seal. So then it's not N95 anymore. So, we've learned a lot of things about masks in the last year. I am happy I could share some of this with you. I had a lot of fun. I hope I could tell you something interesting. So I'm actually going to stop my share and take some questions. I have a lot more slides. If necessary, I can show you some of them. But let me stop my share and take questions, and then we can go back and let's have a discussion, is what I feel. So, yeah, I'm sort of ready to take questions.
Yeah, it was quite interesting, and we didn't know that so much of physics is involved in the humble mask. And I don't know what the masks that we are using, whether they are helpful or not. It's just a placebo effect that has been going around. I really don't understand.
I think if you have been using a mask properly, I mean, the problem with I need to share my screen again. Actually, I didn't show you my thank you slide. The problem with Indian thing is that we don't we don't wear our masks properly. Most people wear their masks here or here and don't cover the mouth and nose. If you go in the train, I mean, I travel by train every day, hardly anybody wears a mask correctly. So if you wear a mask correctly, they're actually very, very, very helpful. you know, and I don't know, I myself, for example, have noticed that earlier in Mumbai, there's so much pollution and dust. In a year, at least 3-4 bar, I would get some cold cough thing, which is dust related, allergy related. That has actually stopped after wearing masks. I rarely get those kind of things. So I think, no, it's not a placebo effect. It is actually very, I mean, masks are probably the best and the simplest way one can tackle an infection, airborne infection like COVID. And remember, everybody doesn't really need these N95 masks. Even a cloth mask or a simple mask is sufficient, because most of the virus is coming on a water droplet, which is much larger. Not by as a, yes, there is some virus in the air as aerosols, which are very fine, but most of the load is when somebody coughs, and those are droplets, larger size. We also know that right now, I mean, okay, this is not related to masks, but we also know, because I'm now in touch with this community and with doctors, that surfaces is not important. Surfaces is a very good excuse, because आपने आपका surface sanitize nahi kiya, haath sanitize nahi kiya, the blame is yours, right? Tackling something nationwide, which is the government's responsibility, it's easy to say ki sanitize karo sab kuch. Sanitization is important for other diseases, not for airborne diseases. So all this haath sanitize karo, COVID doesn't spread from surfaces, not at all. On most surfaces, the virus will die very, or get inactivated very soon. So we've learned a lot of things. So okay, I see some, I don't know how. Okay, I can open the Q&A. Okay, and I can open the chat. Let us see. Okay. So in a chat, there is a question from Dr. Shripati about how face shields work. Very good. Did you do any studies on it? Did we do any studies on it? No. Do face shields work? Yes, partly. Again, what does a face shield do? You take something which is transparent, hopefully, and put it in front. Of course, it will allow you to breathe whatever is coming in, especially in crowded places. If somebody is going to go hatch in the middle of the train, crowded train, you're in front of it. If you have a mask, the full thing just comes and hits your mask. Hopefully, it doesn't happen, but somebody sneezes right in front of you. If you have a face shield in front, you get a little bit of additional protection. Okay, so yes, it does give you a little bit of additional protection. It forces the air sort of come around, but that's about it. It's not a mask is much more important. A face shield is not a replacement for a mask. Okay, there's a Q&A box. Let us see this. Okay, Yashashvi is asking, constant wearing of the mask reduces lung capacity, or is it affected by wearing masks? So is there any way that can be countered, etc.? Okay. Let me clarify this. Lungs, आपके फेफड़े जो हैं, that capacity is that capacity. The mask is outside. The mask is not doing anything to your lung. What is the mask doing? If the mask is breathable, how do you breathe? First, let us go down. I like to explain science to children, so I'm trying to make it as simple as possible. Sorry if this is not the correct way to do it, but you are all scientists. You know Boyle's law, P1 V1 P2 V2. How do we breathe? The diaphragm goes down, the internal volume is forced to expand, that creates a lower pressure region, air goes in. You push it up, the diaphragm goes up, pressure goes up, air is expelled out. That is how you breathe. Simple Boyle's law. What is the total volume exchanged? Okay, not the lung volume. The total lung volume is large, might be 10 liters. But the amount of air that is exchanged in every breath is 500 milliliters. Okay, now 500, half a liter. Half typical, okay, average. Half a liter. Of course, if you're that's a lot more, you can breathe more. But half a liter, you take about 10 to 12 breaths a minute. So there is a flow rate. What this guy is doing is adding impedance in front. If I'm adding a lot of impedance, if I take something like this, which is tight, adding a lot of impedance, which is not well designed, then you will not exchange half a liter, you might exchange 300 milliliter. Lung capacity is the same. The amount of air exchanged may reduce if the breathability is not good. So a mask whose breathability is not good is a problem. However, in most cases, the mask is loose. If the mask is loose, air will just come from inside, not come from through your mask. So it doesn't change the lung capacity at all. People have made measurements. People have put carbon dioxide sensors inside. If you have a good mask, which is, N95 is a US certification, you have IS certifications in Indian standards, Chinese KN95, Korean KF94, European, what is it called, FFP2, all these masks have to meet a certain breathability constraint. The breathability has to be so much. At that thing, there is no buildup of carbon dioxide more than anything else, something. So they are perfectly safe. They do not reduce the lung capacity. Okay, even if you wear it 8 hours a day, it's okay. If it's a good mask, not a bad mask. Okay, so that is the one question I have. Let's see if there's anything more on the chat. Chat. Kidhar gaya? Hey, my chat has disappeared. Okay. Okay, thank you, Dept Kumar. How many times can one wear an N95 mask? Sandeep Bharadwaj, very good question. And then Vishwajit is asking, how many times can an N95 mask be charged? Okay, that's a more difficult question. How many times can one wear an N95 mask? Now, this, as a scientist, is an incomplete question because here is a mask. I wore it. I took it out. I wear it again, I take it out. I wear it again, I take it out. Okay. You do this 20 times, this elastic will go for a toss. Okay. So nothing has, I've hardly worn this maybe 5 minutes, but I will kill the elastic. Now, if you say how many times can you wear an N95 mask, remember that by itself, your air that you breathe out is humid air. Okay. So that is slowly going to remove that charge. The guideline is 8 hours. After 8 hours, they don't guarantee that the N95 mask is supposed to filter N95 level. So you should not wear your mask for more than 8 hours. Now, after this, if you keep the mask aside, decontaminate it and use it. So we have shown 5 to 10 times decontamination. People have also said that if you take the mask and leave it, you know what I said, just leave it in a bag, use it on day 6 or day 7. Okay, you can use it. But what happens, remember the mask is continually trapping particles. So overall the breathability will go down. And the air you breathe out is humid, that's being trapped on the inner surface. If you're in Mumbai, if you recycle a mask like this, after 3-4 times, fungus will start growing. In the hospital, the biggest problem is with the heat treatment, nurses wear masks. If any lipstick gets stuck to the mask, lipstick is a waxy material. You put it at 70 degrees in the oven to decontaminate, or 75 degrees, that thing melts and goes everywhere. That starts clogging up your pores. That's going to change the filtration. Then you have to throw that mask away. So how many times can you wear it? Depends on how much you wear it. What is the dust load around? How carefully you use it? And sometimes these cheap Chinese masks, the strap just goes off. So, you have to be careful. It's often not the mask material. Sorry, that's a long answer. How many times can an N95 mask be charged? Well, we have not done comprehensive experiments on charge. We have again shown that you can do it 2 or 3 times, but we didn't really go to a productization of it or checking how many times can it be charged. Charging is not a very easy thing. It's not something you can do at home very easily. Okay, so it's easier to just maintain the charge by not discharging it rather than doing this recharge thing. Spectacles get foggy with masks on. What is your suggestion to prevent it? Wear your mask properly. If your spectacles are getting fogged, you're not wearing your mask properly. If you have so this is a horrible mask. It does not have nose clip. It doesn't have dono side pet. There's no nose clip on this. If you have a good mask with a nose clip, okay, you have to bend the nose clip around the contour of your nose to make sure that it is a tight seal. Now, remember that nothing, let me, I'm not a doctor, I'm not something, but I've been playing with masks for a year and I'm a physics person. The year, right, is not designed to take load. If you put a thing with a rubber band, like a strap, it will never be tight to guarantee no leakage. Right? You can't put 10 newtons on this. You can maximum probably put 1 Newton force. if you have all N95s, by the way, the US N95 cannot have ear straps. The Chinese KN95s have ear straps. Any mask with a ear strap is not an N95. The only mask which will fit are masks which fit behind the head. Your skull is strong. You can put 10 Newton force that you need to seal. You need to seal. You need to put force behind your head. Seal it behind your head. If you have this mask with a rubber band, take another dhaga, nada, whatever, tie a small piece of nada to this and tighten it behind your head. As simple as that, you'll not have a leakage problem. Or take micropore tape, which is what they do in the hospitals. You have a poorly sealing mask, take some micropore tape and just put some tape and seal it. That's another thing you can do. But otherwise, masks is something which is, it should seal properly. It should not fog your glasses. What are the best masks available that you can suggest for us if possible? Well, I can't recommend any brand or anything of that sort. I can share my data with you. I have shared my data publicly on washing masks. It's on Twitter. I can share my data. I can give you all the data on masks I have measured. Masks I have measured, I can tell you that these are the masks I have measured. They have passed. Okay. But remember that, for example, the Venus 40, this is okay, 4200, the Venus 4400, a very, very good mask. There are only two N95 manufacturers in India, Venus and Magnum. Okay. But they are so good that there are also fake Venuses and fake Magnums. Okay. Venus, if you go to the website, it has a thing on how to identify a fake Venus mask. Right. So you have to be very careful that the mask you have is not a fake one. Okay. Because there are lots and lots of fake claims around. I mean, I can show those slides, but there is a huge problem with fake masks. All right. Any other questions? Q&A. Where's Q&A? Q&A. Oh, wait. There are more questions. No, that's chat. There's Anand's question. Okay, let me see. There's nothing in Q&A, so let me close this. Anand has a long question. There are a variety of masks. Ha 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 ha. Excellent. Can I share this? So let me just. I'm just gonna. Anand, great question. Anand, great question. Let me share the screen temporarily and see if I can show you a figure that I want. Okay, so first thing, I have told you that masks with valves are bad. That you agree. Now, this is thing. Beware of advertisements and hype. Let me minimize my video. So you remember that N95 is a US standard. There are standards of every country. You can't make up your own standard. Okay, so there is, Wildcraft is selling W95. Somebody else selling LN95, SS95, kuch bhi. It doesn't work. Also, beware of any mask which says tested by Citra. Citra has said that Citra is the South Indian Textile Research Association. The government has mandated them. They are a fabric tester. Remember, they do not test masks. They test fabric. So if you give Citra a mask, what it does is it punches a hole from the mask, puts that in that mask tester and tells you the filtration efficiency. It doesn't do a fit test on a mask. Okay. All these washable, reusable, etc. I have every time on Amazon, I go and challenge somebody, send me your data after 30 washes, please. I'd like to know the filtration efficiency. I have washed masks and I can tell you the filtration efficiency of various masks. Okay. But so people will say that we make all these SS96, SS99 masks. They are 5-ply. And then they say they're all surgical masks. Arey Baba, a surgical mask is designed to have gaps at the side. The design is so that the air expelled out goes at the back. That's the way the air goes backwards. That's why it's designed. It's not supposed to be 99. It cannot be 99% at 0.3 microns. Okay. Then somebody else says that it is tested and certified by Citra. No, you can't say this. You measure it, we get much less values. Citra has put out a notice saying that we are not a certifying agency for face masks. Then you see, then this is from Flipkart. It says bacterial efficiency 99.5% at 3 microns, but then it says N95. So this is the difference between 0.3 and 3. Okay. Anyway, this mask has a valve. You can throw it away. So we have actually should stop sharing. So I have not found any mask which is N95 and will remain N95 after washing it with dilute soap water or with sabun ki tikya and water, or surf powder and water. Okay, you will. It may not be a bad idea. I wash my masks. I will tell you, I wash these masks. These masks I've washed 20 times, right? They will not be N95. They'll still be 75, which is probably good enough for most of us. Okay, still better than a cloth mask. Now, you will cut open a mask and not find this thing because in many cases the layers are fused together. Okay, so this, don't worry, there is a big difference between vendors also. So if you cut open a 3M, I can tell you, I have cut open a 3M mask. A 3M mask, it's very easy to find that there are actually 6 or 7 layers in it. You can cut open another mask which is still 95%. It will apparently have only one layer in the middle, one outer, one inner, and one middle layer. If you take a tweezer, you can actually peel open that. What they do is they take spun bond melt. It's called SMS layer, spun bond, melt blown spun bond, and they fuse it in a thing to make it a thinner thing, to make the breathability better. They've used thin layers. So it will have, you can take a tweezer and remove the layers. You'll find there are multiple layers. So just because it has only one layer need not be that thing. They could have multiple layers which are fused. So that's one thing. Whether fumigating it with 0.5% H2O2, I don't know. I have not worked with H2O2 or silver nitrate. To me, the simplest way is to use heat. You can use dry heat for something. Be careful in a microwave. Okay, don't put masks in a microwave unless you're sure that it doesn't have a metal strap. The metal strap will spark. The metal strap can damage your microwave as well. So don't, if the metal nose clip is there, don't put it in a microwave. Otherwise, you can also boil your water in a microwave and keep the mask in the steam above it. So there are it's possible to do it at home. I haven't tried doing H2O2 or silver nitrate. Wearing 2 masks is better than wearing N95 mask. Depends on the mask. So again, I don't have the data in this presentation, perhaps. Do I? So basically 2 masks is just additive. Okay, so if you have one mask which is a very bad 30% mask and you have another which is 70%, you will get 70% and then uska jo bacha hai, uska 30%. So it is not equivalent to an N95. If you're wearing a good N95, one mask is sufficient. If you're wearing surgicals, I would recommend a surgical and a cloth. So I didn't bring my regular masks with me, but sometimes what I do is I often use a non-woven mask inside. This one obviously has leaks on the side. Then I use a cloth mask which has a cloth mask with a long cheek piece, and this I tie behind and sort of tighten this part. I've done that also, but this is not, again, I mean, I don't know if it's a substitute for an N95. I have to travel every day by train, so I make sure that I feel that I'm reasonably well protected. So, but I haven't made too many measurements of this. All right.
So I have one question: whether these cloth masks are effective enough? These kind of masks.
How many layers?
2 layers.
Cloth, I would think you need at least 3. And if you are stitching your own mask, purana banyan le lo, purana, you don't have to get a fancy mask. Okay. Okay, if you want to make matching mask कि मेरा ड्रेस ये कलर का है, मास्क भी वो कलर का चाहिए, वो सब तो है आजकल. जैसे पहले वो people used to make whatever salwar kameez with ये इसका साथ matching hair band or something. Now matching mask भी बना देता है tailor. But be very careful. If you are making mask with cloth at home, at least 3 layers. At least 3. One simple trick: make sure that you align the fiber. So you can see that any cloth has certain, this is not non-woven, but any woven cloth has a certain fiber ka direction hota hai. right? Keep one layer this way. Don't keep all layers the same. Then it's much easier for a particle to go through. You keep one layer this way, one layer at 45, one layer this way. Then the chance that you have interception is much higher for a cloth mask. But three-layer cloth masks, you can get up. I have measured up to at 3 microns, 95% plus. At 0.3 microns with 3 layers, you can even get 60%, 65% if you design the mask correctly. Otherwise, it will be 20%, 25% at 0.3 microns. Okay. Anything is good. Even your dupatta is good for larger particles. That is fine. For the smaller particles, a little bit of design and you can get a much better mask.
And this, whatever we do, sanitize our hands quite often. Whether it's necessary, because I have heard from the surfaces we don't get any viruses.
You don't get exactly. Yet, every place you go, they measure temperature. You're useless because those things are so inaccurate. Most cases where they measure my temperature, I should be hypothermia hona chahiye mere ko, hospital jana chahiye. But the hand sanitization also, this is another thing. Beware of the sanitizer you buy. You need at least 70% ethanol for it to be effective. Nowadays, I measure every batch of sanitizer, especially if we are a government institute, we have to buy on GEM, this portal. Half the sellers there are selling you adulterated stuff. 70% alcohol likhte hain bottle pe, it's sometimes hardly 50%. Once it was so bad, I even lit a match to it and it would not burn. Right? So, most of these sanitizers are I think you can, if you want, wash your hands with soap and water. It's good enough, right? All the sanitization everywhere it's a game. It's a natak. It's like dikhana padta hai ki haan, we are doing something.
So, any more questions for Dr. Arnab?
All right, thank you all. I hope I could tell you something interesting. I hope you found it interesting, and I do hope to come and see your institute at some point. I would love to learn about everything from the Carrington event that I've always heard about to all the stuff that you're doing now.
Right, sir. It would have been a pleasure if you had come to our institute, but anyway, the things are not in our favor right now. But maybe next year we can arrange a physical talk in our institute. And I thank you for your precious time. And we were not aware about all the experiments that have been carried on the marks and all the things, and the kind of jugaad and kind of innovation that you carried out at TIFR and at your institute. So I thank you very much for your sharing all those anecdotes and your
I will
experiences.
leave my email in the chat in case anyone wants to contact me. Please feel free to ask me questions. Yeah, I will be very glad.
Right. I think we'll end this meeting. I thank director and our Mahendra for arranging this excellent session. And if anybody has any questions for Dr. Arnab, I think he's shared his email, and you can directly get in touch with him, or you can get in touch with him through me as well. So I thank you all for being here and participating in this excellent talk. Thank you very much, sir.
Thank you.
Bye. Stop.